Next up, we have Kirils with the leak of billions of passwords.
Cold winter morning in Russia. Ivan comes back from his work to his family. He spent his whole adult life working this trade, working in this business. He's been dealing with copyrighted works. He's creating added value, creating written documents, creating authorship. And today he found out that someone has stolen his life's work and is reselling it at a cheaper price. This is a story of Ivan, or maybe he's called some other way in real life, and how he lost control of his stash of passwords. So before we get to that story, let me explain for those of you who are new to the criminal underworld of the IT, how passwords leaks work. Any end users here? Anyone who would consider themselves not a hacker, not a programmer, just interested in computers? Yeah, we have some. Okay. So some of the end users would say that strong password is important, and everyone says that, and it's true. But the leaks don't happen from your end device. So mostly it's not your phone or your laptop or your home computer that gets hacked. By sheer volume, most passwords come from your service being hacked. Like, for example, in the old days, well, actually, we don't have to go back to the old days. Facebook gets hacked here and there, right? So large companies do get hacked, and they did get hacked, and now it happens even more. So that's where the leaks come from. The normal scenario of how password lists come to be. So we have Ivan or whomever, I don't know his real name, but according to the handles it appears it's a male, but who knows. So Ivan is going to hack stuff. But before that we have a user, let's call him Bob. You see him on the screen. User would register to one or more of online sites. Let's say he's a blacksmith, so he frequents blacksmithing forums. He would create an account. Bob123 with password, let's say password 1, because you have to have digits in your password. And he would also create, some more accounts at some other forums. For example, he loves to ride horses, a horsing forum, maybe a social network like Facebook or something else, Twitter, Light, whatever you have. But then a hacker comes along and hacks one of those services. And the password hashes, or the passwords, depending on the configuration of the service, will get leaked. The hacker will manage to get them. Now, what I have a small problem with these days, a small side note, is that researchers do not really differentiate leaks and open databases anymore, right? We just had this Facebook leak, which was a scraped database, not actually owned by Facebook. I'm still not sure if it's actually a leak today, because maybe researchers just found it, didn't download, and assumed, okay, there it is. So there's a difference between that. But leaks do happen, and hackers, when they see a database like that, they will download the whole database, and that is a leak. That's what happens. And a different hacker might download some other database. And you see our Bob here that uses his username, Bob123, because that is his username, and his password, password1, because that is his password. On all the sites will get compromised on all the sites because the password is the same, right? But there's a site that Bob doesn't use, and the different hacker gets a database out of that site. So what happens then? Well, in the old days, hackers would just, shared password lists with friends. These days we have economics of crime, not only crime on the street, also crime online. It's all quite well structured, quite a good hierarchy actually. So what happens is they would sell, in this case, for some rubles, because I came to the conclusion that this leak originated mainly or all together in Russia. So for some rubles, this would be sold to someone who would then combine all the leaks, all the data in a huge database, and then go sell it on the black market, on the dark web usually. Usually these databases are not readily available like to you and me if you're not researching that. You can't just Google password database and get that. You can get something else. You can get some smaller databases, some leaks that have been reprocessed, but these original ones it's quite hard to get. So dark web, or at the very least, you have to have knowledge. You have to use this gray web where you have to know someone to get inside. It's not on darknet per se, but you know it's hard to get. And then in this case, it was being sold for some dollars to other hackers, and they have different use for that. They might use password stuffing, which means they take your password and try it on other services, on all the services that they can. They will try your username and password and see if they can get in. They might want it because they want to steal your identity, or because they want to take over your social networks. Anyone remembers the hacks of around 5 years ago, I think, where Twitter users were targeted for their short usernames? So that happens. And these people are ready to pay the price. It's not a high price. It's usually under $100 for this compiled password user list without credit card numbers and stuff like that. But you know, as it happens in free market, especially in free market that is a crime market, some users, some hackers might do additional illegal stuff. And illegal stuff on this picture here is denoted by the red lines. So they might you know, try to resell it back on the black market. Say, if it's $40, I'm going to resell that for $20. If it's $90, okay, how about $40? A better deal, same data, everyone wins, right? Except the original creator of the data. Well, users lose anyway. So what happens there, and the last step is, at some point, someone is going to also leak the data somewhere outside the dark web, and it's going to become available. That's when researchers get more easy access to it, and that's what happened here. So we're going to take a look at some screenshots of the gray forum, cracked.to, where this stuff was happening. So here we see a profile of a hacker named Corpse. He calls himself ethical hacker and coder. And there's a line going through his nickname, which means that he's banned. Too bad. You can also see that he's been there for less than a month. We'll see what he was doing there a bit later on. This is the advertisement for the leaks. So it says you can buy cloud access with combos, which usually means username and something, like username and password, which is about 1 terabyte of data. And you can actually see all the folders there that are in there. And the access for life, I mean for eternity, not jail sentence for life. So access for eternity is $45 here. So that's how it was being sold. This is Sanix here selling this stuff. Not anymore. I think it's not being sold anymore. And Clorox was doing something similar on the forum. So now back to Corpse. Here we can see that Corpse has posted collection 1, collection 2, collection 3, 4, and so on. And all of the collections here. The links are available to forum members only, but that doesn't matter. What's interesting here is the note he added. So he says, I'm the creator of these collections. The reason why I leaked my own collections, which I used to sell, is because Sanix sold them and scammed people. So yeah, he decided to take Sanix out of business, out of stealing his business and out of his business, and got viral in the media, as he says himself. And then we have a different user here with some interesting comments towards Sanix as well. But some people, some hackers on the forum also made my job easier by actually combining everything into one neat download. So that made stuff easier. That's how the leaks happened. This happened in January 2019. It started end of 2018 and happened in January 2019. But the question is, one of the questions that we have when researching stuff like that is, how old is the database? If the leak to the gray area, to the gray net, or the open internet happened in January this year, does that mean that the passwords are actually January this year? No, it doesn't necessarily mean that. So that's one of the questions we're going to look at. Before that, so we download everything, we take a look at what we have. This is what we have, mostly text files, yay. So 4/5 are text files, which means they should be easy to process, and then we have some archives, which is not that nice, because for one, that means that if you say bought a 1 terabyte drive to analyze this and you filled almost 1 terabyte with this, you can't really extract it anywhere. And the other aspect is that text files usually compress quite nicely, which means that it's going to be a lot data. Before uncompressing it, of course, we look around. If we look again at this slide here, we have a bunch of other formats, 0.4% other. And the question, what kind of things we have there? Well, we have interesting stuff in there. For example, we have a Word document. It says in Russian, we are renting out this website. Not selling, we're renting it out. And what we see on the slide actually is rankings for different keywords on different search engines. So you can, buy this stuff and do your dirty business, or maybe legitimate business if you rent this. I've actually heard of companies, legitimate companies, a newspaper in Latvia, that are renting their domain name, like not from the registry, from some third party. So maybe some legitimate business might use that too. So why was it there? I'm not sure. I have two equally likely possibilities. Either someone was trying to advertise their side business, or they just don't care what they put up there, because the quality of that stuff is quite low. There's everything in there. For example, there was this Word document. It actually has had active links to the database administration system of where this was copied out from. So the attacker opened up the system, Control A, C, Control V in the document, and there we go. There's also pictures. Just random pictures in there, because why not? The message there says in Russian, "Fight me." And we have some Python scripts. I would love if for every separate database there would be a script to process it. So this opens up a specific dump.txt and processes it in a format that's easily usable in Python later on. Unfortunately, there are only like 4 or 5 of scripts like that. And the structure is basically we have all dumps from everywhere, as we will see in a minute. And since it all happened just by hoarding data from different leaks, which overlap in time, because as I told you, if a leak happened, you don't know how fresh the data is. And sometimes data gets leaked again. It happened once again in Latvia, where I come from. So there was a huge storm in the press. Press was saying, "Oh my God, the government was hacked because the passwords of their system leaked." And it's true, they leaked. Yes, and they had the email addresses of their customers, so mostly Latvian citizens, and they had the passwords associated to those accounts. But the leak happened 4 damn years ago. And we already talked about that 4 years ago, but then someone found it again, sent to the press, "Hey, a leak." So that stuff happens, and it happens to black hat hackers as well. They also sometimes re-include the same stuff again in the leak, because file names changed. Hash sums may change if you add a carriage return in the end. So if we don't look at these small changes, right? If we just look at the files as such using hash sums, 1/4 was matching something already in there. So basically, that's good for me because I have less to process. But after removing duplicates, at this point I extracted everything, of course, and even better picture appears. Almost everything is text, which is good because text is easy to process. I will tell you about my method to process them in one of the slides, so you can do that as well for other data or for this data if you want to repeat the research. We do have 0.1% empty files, so that's a hacker's thing. Those of you who have been hacking for let's say 20 years know that in the so-called scene, sometimes you add files just for their file names. Like it happens in the piracy scene, it happens in hacking scene as well for your tool. You just put your message in the name of the file and that's it, and the file's empty. So that happens a lot here as well, 0.1% empty files. So file size wise, what do we have? We have, after the extraction, we have 37 gigabytes collection 1. These are before the extraction actually. We have 10 times more collections 2, 3, 4, 5, and anti-public. Apparently, anti-public is the name they use for a database that has never been published outside the darknet, which is not the case anymore. Then we have 12 billion special, which is one file. That's one file of 90 gigabytes. And it's super clean. It's like username, password. It's perfect. So easy to use. Then we have big DB, big database, which is around 600 gigs, obviously. So that totals to about 1 terabyte of data. This is before the extraction. When we extract it, we have 1 terabyte more. So we have 2 terabytes of data to process. It does take some time. I've been doing this research since the leak, since February. This is not the first time I give a similar presentation, but this presentation has more data, different slices. I'm looking at it a different way because it takes a lot of time to process. For example, extracting one country, entries for one country out of 2 terabytes, out of the database, I wouldn't call database, out of the dump, can take around 4 to 5 hours just extracting one small country, not like .com, but like .lv. But in reality, we have 900 gigs because, once again, we look at the duplicates and what we see is that there's a bunch of stuff wasted, a bunch of space is being wasted just because they don't care. But that's not their job, that's my job to analyze the data, to clean it up first. So that's how we see it after the extraction. Duplicate data, duplicate files, not entries, more than half. So there you have it. This happens with potato chips a lot, right? You buy the bag of potato chips and half of it is there. That's same logic happens here. So how do we process them after we have them down to these around 900 gigabytes? It's still a lot of data. The first idea that people who work with web development or with Microsoft tools have is usually, hey, let's import it into the database, which is a super bad idea. I didn't try it, but my presentation collided with a different guy's presentation at a closed event where I was presenting this, and he was doing it database style. Even though it was highly optimized database, his speeds were lower than mine. So my answer is, of course, GNU core utils and some more utils. So those are super nice. If we're talking about hard drive or even solid state drive, it gives you line speed. So the bottleneck is usually the actual media or the actual connection to the file that you're working with. So it gives you super nice speeds. I was working on a USB 3 attached hard drive of 4 terabytes or 3 terabytes, I think. So the speeds were what I could get, like 100 megabytes per second, which is as good as it gets. So anyone used Find? Yeah, we have people, right? Anyone used any of these? Cat, grep, WC? Yeah, super cool commands. They actually help a lot. Then sed. Anyone use sed? Okay, almost the same amount as the previous. That's good. Sed is a bit more complicated, but it's also super nice. And then we have the last one here, which not that many people use, but in this audience, I think we're gonna have more hands than usual. So who's used Progress? Yeah. Thank you, Martin. You told me about that at this conference two or a couple years ago.
Where's AWK?
AWK. I managed to live without AWK here. Yes. But I did use cut with CUT, which is not here. Cut is okay. AWK is useful when you have to swap fields around because the maintainers of cut do not want to implement that. But Progress is super cool, and a lot of people have heard about it. That's great. I heard, as I said, from Martin about Progress. So it's a cool utility. You launch Progress -m, and you get this on your screen. So you don't have to wait around indefinitely, not knowing what the speed of your operation is. You can actually take a look at the time remaining, at the speed, because when you launch a command like that, cut something, all list big emails, which is like half a terabyte file. Well, not in this example, but in general, then you don't want to wait for 24 hours to find out that, oh, it still hasn't finished. Maybe my algorithm is bad. So that's why Progress is cool. So after processing all the text files, and I'm just talking about text files here because I decided I can just ignore the 1% of the files which are not txt, we have this amount of records. That is 26,713,863,611. And if you stumble upon any other presentations on the leak and on the topic, the number may differ because data quality is poor. With the exception of the 12 billion file, data quality is poor. Some text files have binary data in them, zero characters, so zero ASCIIs, and I had to filter that out, and it might have changed the number of entries. So, but still, 26 billion entries is a lot, right? If we look at it from this perspective, it's basically 3.5 populations of Earth. So that's quite a lot. And what do you think? What is the most popular password amongst the 26 billion? Huh? Password? Nah, not password.
1, 2, 3, 4.
No one has it yet. Come on, this is gonna be the winner.
Let me in.
It's 1, 2, 3, 4, 5, 6. It's still that. So it already tells us a couple of things. Nowadays, majority of systems would not accept this password. There are still systems that would, but majority wouldn't. 5 years ago, the largest commercial bank in Latvia accepted that as a password, and that is why they were hacked. But nowadays there's change. So 0.15% is 1, 2, 3, 4, 5, 6. But in the top we see the other passwords that you mentioned. So we have password here, and we have 1, 2, 3, 4, 5, and stuff like that. So password 1 is actually not that common. It's like top 50 or something. So it's a relatively secure password. Depends on the resources of the attacker. So one thing we did with the data is we took a look at this distribution. So some of the entries actually had the IP address of where the user was either logging in or registering from. But since there was no guarantee that it is a registration IP address, or that it is there at all, or that it's not a phone number instead of an IP address, we didn't go that route. Also, only minority of records, like less than 10%, had the IP address. That's why, contrary to some other researchers, we decided we should go ahead and look at the email addresses, which is not that cool, but we can get answer to one of the questions that we were asking. Where did the leak originate from? So, .com domains, more than 13 billion entries, so more than half, were .com email addresses. That is obvious because .com is the oldest, one of the oldest domains, TLDs, sorry. Then, around 6 billion .ru, so Russia. Then we have the next category, which is more than 1 billion. They have Germany in there. And then we have some more countries coming in. For example, here, for more than 500 million, we have .net, we have France, we have UK, and so on. So we see where the concentration is, right? Here, for more than 100 millions, we have Italy, Poland, Czechoslovakia, Japan, and Brazil, of course. And here, so Canada, Ukraine, Spain, China, Australia, Taiwan, and .edu. So those are the popular ones, and it clearly begs the conclusion that Russian hackers hacking Russian users. It looks like that, because .com is used by everyone, right? And we have some more here, and of course the rest, which is less than 30 million. Now looking at the slide, even though I've looked at it a couple of times, I'm not sure if Antarctica actually had anything, but it's in there. Well, anyway. So if you zoom in on Europe, this is how it looks. So you can try to find your own country and understand the probability that you're in there, that your domain is in there. If anyone actually uses their national .tld for email, yeah, we have 15 people doing that. So yeah, you can take a look if you don't want to download the 2 terabytes. So then, of course, it's interesting to look at the governments, because governments use their national TLD for emails. That's what governments do. And the US is number 1 with 44%. Then we have UK, Australia, and stuff like that, right? So that's that. Particularly coming from Latvia, we have this rivalry between the Baltic states, between Estonia, Latvia, and Lithuania. Please don't mix up Latvia and Lithuania, unless it's on purpose. Then it's funny. So I want to take a look at the 3 Baltic states. This is what I got. So these are unique email addresses, and this is the difference. I've given a similar talk before. For this talk, I've actually done it right, finally. I mean, I had scientific explanation, valid explanation, I think, for why I didn't remove duplicate entries, because it is quite possible that Bob123 uses the same email address and the same password at multiple sites. It is quite plausible. But the data didn't make much sense, so I decided for this presentation I will filter all that out, and I only include every username once. Right, every unique username once in this slide here. So unfortunately, when we're going to look at the users and passwords, it didn't make much more sense, just a bit more sense. But here, Latvia is still the leader, so we still have a bunch more addresses from Latvia. If you look at the Russian population, then Latvia leads. Estonia closely follows, not like here. Estonia is more than 50% under, and Lithuania almost doesn't have Russian population. So it kind of makes sense that Latvian addresses are more targeted, because much of the information warfare of Russia extends into Latvia and a bit into Estonia as well. Okay, but since this is a conference in the Balkans, I included now. I'm struggling at how to call them. I'm going to call them countries. I'm sure you will forgive me if any of those isn't a country, but I think it's safer for everyone if we just call those 3 countries. So we have Montenegro, Serbia, and Yugoslavia in there. And we can see that compared to the Baltic states, it's nothing. So Russia is quite far away relative to the Baltic states. So, you know, not that many hits. And for Montenegro, it's .me, right? So everyone, well, not everyone, but lots of people have .me just because it's a cool domain, and not because they're affiliated with Montenegro per se. This conclusion can be corroborated by a different set of evidence that we will see in some of the next slides. Now, here are some slides, and the slides will finally, for the first time ever in the history of me presenting on this topic, will be made available today on my site. So you can take a look at all that later, but here we have top domains for every TLD of those 6 TLDs. So we have, of course, EE, we have LT, of course. For example, one LT here is a top. It's quite popular one in Lithuania. Hot.ee is a popular email provider in Estonia. For Latvia, inbox.lv is basically the popular one. But the zinger here is that 1LV, which is place number 2, has not been functioning as an email provider for the past 5 or 10 years. And we have quite a lot of emails coming from there. So I would like to conclude from this data that means data is super old and crappy, but it also might mean that users don't care updating their email addresses. They just create an account 10 years ago and they use it daily, but it doesn't matter that the email is wrong. Maybe that's the case, because email revalidation isn't a thing in most accounts these days, which is good. I don't like machines annoying me by sending me random emails. So for Montenegro, we have binka.me here and dropmail.me. For Serbia, hotmail.rs. Is it actually run by Hotmail, the Hotmail, or something else? Is it local? No? No one knows. No one is using that. But that's number 1. Interesting. Then Open Telecom RS and SBB RS as well. And for Yugoslavia, you have evnet.u and ptt.u. Now, let's compare the governments. We didn't see any of these governments in the first slide, so let's compare the governments between themselves. So if we filter out all the governmental addresses from these 6 countries, Latvia, once again, is number 1. You would expect Serbia to be number 5, but Serbia is number 2. So it would indicate that Serbian government, well, because of the nature of the leak, I wouldn't use the word was attacked, was targeted, I couldn't use that, but was less careful or using the wrong sites or using their work email address for private purposes. once again, we're going to have 6 slides which you can take a look at later. After the talk, which governmental addresses for Estonia, which for Lithuania, then for Latvia. For Latvia, you can see a huge part is other, right? So the tool only includes top 10 addresses, and there's a bunch of addresses. If we look at them, so we have Estonia number 1. I think that's in Ministry for Information. Lithuania is Statistics Institution. Latvia, the Foreign Affairs Ministry. For Montenegro, it's just gov.me. I guess that's because that's how they set up their email address mostly. I'm not sure. Then we have this for Serbia. What is that? NSZ. Any Serbians here?
Unemployment office.
Unemployment office. Oh, okay. Lots of free time on their hands. For Yugoslavia, we have a sergov.eu.
These don't exist anymore.
See? Okay.
Long time.
And yet we have them. So, looking at that statistics that way is of course interesting, but what actually brings home the message on the validity of the data and the validity of the approach of looking at the email addresses at the domains rather than at the IP addresses is the usernames. So, what do you think is top 1 username for, let's say, I don't know, and Latvia? Okay, let's start easy. Top 1 username for Serbia. Good. I've never registered anywhere with my root email, but I still get spam. Like a bunch. No, it's not root. So for all the countries, top 1 or 2 email is info. But obviously for Serbia and Yugoslavia here it's office. But top 2 is info anyway. And we also start seeing some national names in top 3. So we have Andres and Martin for Estonia, we have Thomas and Andrius for Lithuania, and Janis for Latvia. And admin, of course, for Latvia as well. And here's the rest of the top 10. I think it's top 10. So we do see quite some national names. Yeah, sure, you can take a photo, but the slides will be available in 1 hour as well for your use. And so it makes sense, right? And what also makes sense is that Serbian and Yugoslavian names are basically a match, right? It also makes a lot of sense. We see an overlap in there. Now, the next slide will be what? Yeah, top passwords. Same countries again. So, number 1 password is 1, 2, 3, 4, 5, 6. Yes, that's number 1 password, except for Montenegro and Serbia. We'll get back to that in a minute. If we look at number 1 password, this is what we get percentage-wise, and this is where this approach makes more sense than the previous approach, filtering out by unique accounts. Because previously these percentages were around 1% or under 1%. Now we can actually see the real prevalence of the bad password. And we also see that Latvia is safe, because it's only 1%. But on a serious note, it's not because, I don't think it's because Latvians are more intelligent in choosing their passwords. I think the thing is that Latvians had much more data leaked, so many more records were leaked for Latvians. So I guess stupid users get leaked more often. So that's the message there. Number 2, right? We have some reasonable passwords. This 1Q2W3E is quite common these days. And number 3, we finally see some national passwords appearing. So some passwords that include a dictionary word of that language. So here, for example, indicated in red is Lithuanian word lopas, which means animal. And if we look at the rest of the top, we also, if you look at the rest of the top, we see some more words from the dictionary, but only in the Baltic states. I mean, maybe I don't know the Balkan languages that well, but I didn't find any local words in there. So yeah. Yeah, I don't think that's a local word. But still, If you look at the column, the last column and second to last, once again, we see quite an overlap, which means that people may be using email addresses, or were using email addresses interchangeably, or maybe at some point they switched over to the Serbian TLD and reuse the same old password. So now, of course, we have to ask ourselves, what is this, right? What are these top 10 passwords? Well, the answer is simple. I don't know. This place right here is actually why, after presenting last time, I decided I have to look at the users uniquely. So I don't see a password in the top if it has been used by a user and the user is simply included in the leaks 1,000 times. I didn't want to see that, so I removed all that. And each entry now only appears once when calculating the top. And they are still there. So, I mean, maybe it's a data quality, but yeah, I'm baffled. So in Q&A, this will be a special Q&A. You will have the option legally to not only ask a question, you can do a comment. So you're welcome to comment on what the hell was that. Now, let's wait for the Q&A. So, one more thing that I was really looking forward to is some other things that we had in the dump. I showed you some pictures, I showed you some Excel files, stuff like that. But my daily job involves consulting, pen testing, and stuff like that, including software engineering. And I couldn't find any recovery questions leak before. So now I finally found one. I mean, I found a couple, and there were a couple leaks in there in this large leak that had to do with recovery questions. So now my pen testing mind switched on, and I thought, yeah, finally I will be able to understand how users think, how they answer those recovery questions, because that's an easy way to get into your account usually if you have those enabled, right? So this is from a site that allowed users to specify their own recovery questions. And usually I would say, right, it's safer that a user can specify their own question if the alternative is that you choose one question out of 10 from a list. Well, looking at these answers and questions here, I have to doubt that. And you have to make a decision when making a secure system. If you have recovery questions, do you have them preset, or do you allow users to type in whatever they want? Because this is what I saw. So for example, there was a recovery question, who are you? And what that user specified in their account. And the answer they specified for that is, it's me. The original writing is on your left. And there was a recovery question, nil. The answer obviously is, yeah, that's me. Yes. Who am I? Kamil, which is a name in one of the Russian-speaking countries. And finally, QWERTY. And there are two possible answers that people would give to this, right? If you were a hacker and you were wanted to get in, and the system said, please answer the following questions, QWERTY. Right? You could type ASDFGH, or you could also type QWERTY, which is the correct answer here for this one. So I'm not sure if we assume that users aren't inclined and will never be inclined to waste their own time and comfort for security, I'm not sure that offering them, hey, you can type more and have a secure question is a good idea. Yeah, maybe you have some extra option. I want to be secure, and then you can type your question. But other than that, you can offer them to choose from a list. Now, in the final slides, I want to talk about the obvious things you can do to prevent this stuff. Don't do password reuse. I'm not going to ask you to raise your hand because no one will raise a hand, even though almost everyone reuses passwords, for example, for throwaway accounts. But don't reuse passwords, obviously. Use strong passwords. 1, 2, 3, 4, 5, 6 is not a good password. If you use strong password, your friend is a password manager, which helps you remember the strong passwords. Just remember the master password, okay? That's the important part there. And finally, if you have any developers in the room, you should use salting. You should salt your damn passwords. Because the leak here came in different formats. We had email addresses, some usernames, not all were email addresses, but we had email addresses, and then we had a password or a hashed password. And if password is hashed without salting, it makes it super easy for a person with lots of money to just crack all the passwords or all the terabytes of data quite quickly. Now, I'm going to talk for 2 minutes about what salting is, because smart people or simply experienced people or overconfident people like me just come and say, do that, do that, do that, and go away, right? And don't explain what I mean by that. So I thought, okay, I'll explain what salting is for those of you who are not sure what that is exactly or have never heard that. So we have a user for your newly made system. A user chooses their secure password, which is 1, 2, 3, 4, 5, 6. And you being a good developer, of course, you do not store this password in the database, you hash it first. You do not store it plain text. That's the first step. You also don't encrypt it with a two-way encryption function. That is second step. Cheers, MikroTik. No, they fixed that. They fixed that a couple months ago. So you hash it, right? You create a hash. Here is a super simple, lame, short hash. Doesn't matter. Just for the example, right? Now a different user comes by and creates an account and thinks, I need to select a secure password. What about 1, 2, 3, 4, 5, 6? And then you hash that password. And even though the password is hashed, in the database it's the same hash. So that means the attacker, instead of spending twice as much resources, just cracks one of the hashes, because they are both identical, they're both the same. Hashing is good compared to not hashing, but salting is better. So how do we salt? Same users, they come to the system, they select randomly, look at the top passwords. Which top password do I want to use today? Number 1. So okay, and select the password. What your system does at that time, you generate, well, salt can be called a random system generated password, additional password. I wouldn't call it second factor, that's completely not that. But your system generates a random additional password. And once again, important note, it has to be generated when the user enters their new password. You cannot have it just for the system. You cannot have one salt for the whole system. In my job as a pen tester, I've seen systems like that. It's just a bit better than not salting, but salt has to be unique, because now, before you hash it, your system can combine the red and the blue into one string, and then hashing it will result in completely different hash. And then, of course, the question is, how do you verify that the password 1, 2, 3, 4, 5, 6 is legit? When the user comes back a year later and types in their secure password, how do you see if it's legit? Because hash is completely different, right? You can't hash it again. Well, you store this in the database. You store it together with the salt. And even though everything is in the database and it takes almost the same processing time to verify the password, for an attacker, it means that each user has to be cracked separately. And that means that even insecure password like 1, 2, 3, 4, 5, 6 might not get cracked if you use a good hashing algorithm and if there are lots and lots of users. So, this is the top password, and overall, we've seen it in 0.16% of the 23 billion entries. The question is, with the database being old, apparently, because of all the TLDs we saw, because of the names we saw, because of the passwords we saw, database being old, what do you think about the top password this year? Top password January 2019. Yeah.
1, 2, 3, 4, 5, 6, 7, 8.
Good. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that's a good guess. The top password for January 2019 could be determined because this lifetime subscription to the password database in the cloud included free weekly updates. And up to the leak, updates were happening. So you could download a folder with passwords that were gathered just this week. So I looked at that folder of January 2019. And the top one password for January 2019 is 123456 with 0.32% of the entries. Thank you. Now, if there are any questions or comments, I ask you to wait for the microphone before you speak, and the presentation will be available on Kirils.org in about 40 minutes. Also follow me on Twitter. I tweet in English, so it's safe.
One question. Since I know the certain mentality on passwords, can you please reanalyze the certain passwords with 011 and especially for Novi Sad, any password starting with 021, because that's always the case in this place. Reason for that is this is the phone number prefix of Novi Sad, and if you go to a restaurant, the first password you try for the Wi-Fi is 021 in the name of the place, and it will work more than half of the time.
Thank you. Thank you for the question. So there are 858 passwords that include 029 in .rs. So less than 1,000, which is, let's see, which is, so we had 280,000, and about 1,000 of those include 021.
Everyone will be Novi Sad.
Okay.
Thanks for the logic and two addendums. For the government, could you also include all Windows or GE without the O? Because there are a lot of government domains with just GE.tle without the O. And the other thing is, if you want to speed up your reps, take a look at RIP rep and other stuff. There are a few other things that parallelize and are way faster than the regular rep.
If I may ask you a question, since the bottleneck is the disk, how does that help?
With this guy, usually, I think RIP rep also just streams it into memory and fills up memory and that's but you want to have an SSD as well.
Yeah, of course, you want to have SSD, but I couldn't afford the 4 terabyte SSD, that's why I did it on a hard drive. Any more comments or questions? Maybe about those passwords, yeah.
Hi, thank you for the presentation. So I have additional, I would do in your opinion something I used to go for high speed degrees without like 2 million boxes. And there is a regulator by the government that they forced us to have some encrypted passwords, but they didn't force us to do any sorting or anything else. So I'm guessing that's pretty normal in most countries, but what's your opinion? Should the government or the ISP should be regulated by someone to do more security on stuff like that?
That's an interesting question. Should governments regulate technically how secure should the systems be? It's an interesting question because I'm the author of the Latvian national legislation that regulates technical minimum security measures, but it only applies to governmental systems, and it makes sense in a way. If we talk about salting or not salting, I mean, baby steps, right? One of the points I wrote in Latvian legislation is that a system must have a password. That's it. So baby steps. I mean, hashing is already better than not hashing. So maybe in 10 years we can talk about salting. I mean, I'd love to have it immediately, but it all has costs. And I wasn't sure from your question if this includes all the systems. If government says all the commercial systems or even private systems must use hashing, that's a strange thing for a European, if that's the case. But in any way, salting is of course better. Yeah, and but for example, Latvian legislation doesn't have that as well. It just says it has to be scrambled. Yeah. And while we look for the next question, getting back to the previous question, there are no .gv addresses for those 6 countries.
So just a second. Regarding the password in Serbia and Montenegro, It looks to me like it could be a nickname, the wall wrapping, and I presume the other part is a birthday. So it could be that the data set is dirty or something, because I don't know of anything that happened on that day that's of any importance globally.
Yeah, yeah.
Thanks. I forgot.
Well, today I just realized that it's Friday 13th, so be careful. Anywho, .go at this Thailand is using .go for the government. And Japan, about the cracked code, the first form that you showed, it was recently breached itself. So it was dumped, it got more attention dumped on the raid forums, but first it appeared on the Russian forums, including on xss.is, from where the combo list originates.
ISIS.
No. Iceland.
Yeah.
Yeah. Thanks for excellent presentation.
Thanks.
Really enjoyed it.
Thank you for the comment. .go, yeah, some countries use that. None of the 6 countries. That's true. Some countries do use that. I did find a user named Evil Guys Go Fishing at something.
Have you tried looking for your own password?
Sorry?
Have you tried looking for your own password?
Oh, for my own. No, I haven't. I haven't, but I don't have the data here because I don't have the research hard drive with me for .com. I've used my .com domain for basically my whole life. So yeah, I could look at that. But I regularly, well, not regularly, but like once a year, I go to Troy Hunt's website and take a look at some of my email addresses. It's never there, because for all the shitty websites, I usually use some throwaway email or MailNet or I don't even try to make an account. But yeah, I mean, so getting back to the start of the talk, we can never be 100% sure that it's not going to be there. I can't say that there's anything I can do to make sure that my email address will not appear there like in a year or 2 or 10, because it's out of our hands. It's the security of the systems.
So I will ask another question. So do you think that multi-factor authentication is the solution to password segregation?
That is one of the solutions. Passwords. There are companies and there are individuals and non-governmental organizations that their mission is killing passwords. Passwords are bad. Let's kill passwords. I don't mind passwords. I think it's okay, right? Because if a system gets hacked, right, the data is usually available anyway. So the problem is password reuse. If you don't have password reuse, the system being hacked, the data is there, you can access it with or without authentication, doesn't matter. So I think password reuse is a problem. Educating users, I think is possible to some extent. For users that are uneducatable, two-factor authentication isn't going to make things better, because the kind of 2FA that I like, my governmental ID that I put in my laptop, users aren't going to set up. First time I set it up 10 years ago, it took me 4 days to set it up. Last time it was much faster. It was 4 hours, right? Actually, the time before that it was 1 hour, but then they changed stuff and it stopped working on Linux, so it was 4 hours again. So users want simple stuff, like for example, when you talk about 2FA to users, they will say, "Oh, SMS, that works," right? But SMS is damn broken, and I know I've been getting crap on Twitter for saying that do not use SMS two-factor authentication, with different security people saying no, something is better than nothing. But it depends. It depends on how the provider implements it, right? Google has fixed it, Facebook has fixed it, but if the provider can say to your question, "I forgot my password, why don't you send it to my SMS?" Says, "Yeah, sure, here's an SMS with your password," then your additional two-factor just becomes a loophole, right, with SS7 attacks. Okay, I think we are kind of out of timing here. Thank you so much. There's another presentation on Sunday, so come take a look. Bye bye.